2018, number 6, part C. We're looking at the fourth degree Taylor polynomial, and we want to know the error bound. So we know error bound for Taylor series. Everybody's been working on that, and it's, f n plus 1 of z times x minus a to the n plus 1 power over n plus 1 factorial. All right, but this is an alternating series, so that sort of changes things. So in alternating series, you have this. You have for alternating series that the remainder is less than or equal to the next term in the sequence. So what we have to do is find out what's the next term in the sequence. So it's a little bit tricky as to like which term you're on. That sort of threw me for a bit. We're looking for the fourth degree polynomial. All right, fourth degree. But so here's what I found confusing. Here's our fourth degree polynomial, and it occurs when n equals 3. So that fourth degree polynomial is only the 1, 2, third term. And it's that next term, which is really for n equals 4. So it's confusing because we have the n plus 1 here, and we want b sub n plus 1. All right, so it's really going to be the term that has the fifth power of x, but it's really n equals 3. So we're really looking at n equals 3. So we're really looking for our error, which is what they're calling p sub 4 of 2 minus f of 2. So what was confusing to me is it's the fourth degree, but it's n equals 3. All right, so that has to be less than or equal to b sub n plus 1, which is really absolute value of b sub 4. And then so b sub 4, your absolute value of b sub 4 is just equal to oh yeah, for p of 2. So when we are looking at b sub n is equal to negative 1 to the n plus 1 of x to the n plus 1 over n times 3 to the n, all right, the x is this 2. So our b sub 4 is, now we can ignore the negative 1 to the n plus 1 because we're doing absolute value. So we'll just keep a positive number. So for our x to the n plus 1, we're going to do 2 to the 4 plus 1, or 2 to the fifth power, right? Yeah, 2 to the fifth power over n times 3 to the n. So our n, but we're doing n plus 1 now, so n plus 1 is going to be 4 times 3 to the n plus 1, which is 3 to the fourth power. So that's how we get, and you can just leave it like that, all right? But it reduces to 8 over 81, but we can just leave it like that. And there you go. That is part C. That's short, so let's just throw in the scoring for that, if I can find it quickly. If I cannot, then we'll do a separate video, but maybe I can find it quickly. 2, 3, 4, 6. Here we go. Okay. All right. So the scoring for number 6, the first one is 2 points. First 4 terms and general term. It's interesting because does the question even ask for the general term? It says, write the first 4 non-zero terms. Oh, and the general term. I missed that in the question. So I totally would have biffed number 6, part A, because I didn't write the general term until part B. So they might give me still the points because I wrote it in part B, but I should have written that in part A. So yeah, we're supposed to get that general term in part A, and I didn't do it. All right, here's part B, where we're doing the ratio test. So see how they write this sort of big complicated fraction, and I simplified that by taking this and flipping it over and multiplying, but we get the same thing. Your L is absolute value of x over 3, and here's all that. All right, so if you did not consider both endpoints, you get these 3 points. So in order to get the last 2 points, you have to consider both endpoints. So that's the point where we look at x equals 3 and x equals negative 3. And if you don't do that, then you don't get the interval, because the interval is, let me put that somewhere here, down here. Here's the interval of convergence. And you have to have this one less than or equal to and this one less than. Right? Or alternatively, you could write it as a half-open interval, -3 to 3, like that. So you could write it like that. All right. But if you just have x between -3 and 3, you have not written the correct interval of convergence. The interval of convergence has to be open on -3 and closed on 3. And then fifth degree term for the error bound. So that was the tricky thing for me. So I would have probably lost both these points. I had to look at the answer to get it right. Because I was looking at n equals 4 and therefore ending up with 2 to the 6th power. It's a little tricky. But anyway, it's 8/81. And that was 2 points. So that is our question number 6.